This one here is a little bit different than the previous one, where instead of just having an x and y, here we have height and time. And so h and t are going to be represented in as x and y. And so what we're going to do is we're going to have time as our x value and h as our y value. Okay, so this is going to be t in minutes. And again, important to label this here as well. There's my water pump going off again. And this is going to be height in meters. Now, we don't really need negative time because we can't have negative time. We always start with a positive time. Negative time would mean we're going back in time, and that we're not going to do. It's actually impossible at this point, unless you know how to time travel, but we're going to say that it doesn't work. So we're going to use this function here. H equals 350t plus 250, where h is the height in meters, and t is our time in minutes. Now with this one here, we sometimes have to use like different values, and because I'm going to be using really large values, I'm going to use time in, I'm going to go up by, what was I going to do? I think I was going to go up by 5s, 10, 20, 30, no, let's do 10s, 10, 20, 30. Okay, let's go up by 10s. So start with 0 and then go up by 10s, just because this graph is going to become much bigger. Now, if you don't like, notice that right away and you do up by 1s, that's okay too. It'll still give you the same graph. It just might be a little bit tougher to extrapolate on that graph later on. So for the height, we're going to do 350 times 0 plus 250. So we have a height of 250. For 10, we're going to do 350 times 10 plus 250. Now this one I'm just going to use a calculator for, and I get 3750. You notice we got really big numbers here right away. For 20, plus 250, we get 7250. And for 30, we'll do 350 times 30 plus 250. We get 10,750. Okay, so these are some big numbers. Okay, and you notice that we're actually going a little bit more than our cruising height of 10,000, so that's fine. It'll kind of give us the entire thing, so which is good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we're good here. So I'm going to go up my height. I'm going to go up by thousands. So this will be 2,000, 4,000, 6,000, 8,000, and 10,000. And this will be 12,000 up here. And then in time, I'm going to go up by 5. So this is 10 minutes, 20 minutes, 30 minutes, 40 minutes, 50 minutes, and 60 minutes. Always fill the entire page. It just helps to make it a little bit more, it shows the entire thing, okay? And we want to try to use as much as we can. Sometimes we do, sometimes we don't. Technically I could have stretched it a little farther, but I do want to go past 30, and I do want to go past 10,000. So 0 is at 250, so that's going to be down here. It's going to be the point 0, 250. So sometimes those are going to be tough to put in, but we try to put in those values at least as well. At 10, we're at 3750, so that is actually right between, oh, that's right up there. Okay, so this is 10 and 3750. 20 is up at 7250, which is just above the 7,000, which will be right there. It's like 7,000 and a quarter. So this is 20 and 7250. And then 30 is going to be at 10,750, which is right about there. Okay, and this is 30 and 10,750. Shouldn't put actually a comma in there, just 10,750. All right, so those are the points when I graph it out, and I'm going to draw a line through those points. I'm going to try to do as best as possible to get through them all. Now again, when we're dealing with stuff like this, it's actually really difficult to get them exact. Mine are pretty good, I would say, because my line goes through pretty much all of them and it's a straight line. Don't draw a slanted line. Don't just try to match the dots. Always draw with a ruler or some sort of straight edge and make a nice straight line with your points. Now, what we can do here is we can use this graph to try to come up with some answers, or we can use our equation. We're going to use both just to show how they are similar and how they're maybe slightly different because we're approximating some points. So let's say, what is the altitude of the plane after 7 minutes of flying? 7 is right about here. so just above 6. And so if we do that there, looks like based on the graph, we're going to be just under. So if we say based on the graph, okay, you'll notice that we're right around the 3,000 mark. I'm going to say we're a little under. It's just under 3,000 meters. Okay, so that's based on the graph. So 7 minutes, just under 3,000. It might be different again. Depends on if my line is correct, and it depends on if I've even done my approximates here correct. If we look at it based on the equation, so let's do the equation here. Okay, the height is going to be represented by 350 times 7 plus 250. And the height that we're going to have here, I'm going to use a calculator for this. 350 times 7 plus 250 is 2,700. Okay, a height of 2,700 meters using our equation. Now you'll notice, okay, I'm at 3,000, 2,700. So my graph is probably slightly off with the way that I've drawn it out, but we have to remember that the graph is approximate in every case, and so those differences are okay as long as we are showing how we're getting it. So when you're showing on the graph, make sure you draw the lines and show where your lines are going. Okay, well, let's see here. How long would it take for the plane to reach a cruising altitude of 11,000 meters? Well, 11,000 is way up there. So again, we're going to do the same thing. We're going to show it on the graph as well as on using graphical representation. 11,000 is this line right here, right there. And then we're going to draw it straight, try to draw it as straight down as possible. And I'm not quite straight, but it should be just over 30. So I'm going to say 31 minutes. Okay, so let's bring this back up here again. Based on the graph, around 31 minutes, okay, to reach 11,000 meters. But let's see if our equation gives us the same thing. So using our equation or our function, we're going to put 11,000 into our height, and then 350 t, we're trying to find t, plus 250. Okay. Now again, when we use the graph, it's always going to be approximate. When we use the equation, it's going to be exact, and that's why the equation is really nice to use. 10,750 is equal to 350t, and then we're going to divide both sides by 350. Now this is stuff that you should remember doing. We're using algebra in solving this here. Okay, we're trying to solve for our t. We've done a couple of practices with this already. And so we do 10,750, and I'm doing it on my calculator here, divided by 350, and I get 30.71. Okay, so 30.71 minutes to reach 11,000 meters. Okay, now our 31 minutes is pretty close. Okay, when we use our graph, we're not really going to do much in decimals. Okay, unless we have much wider graph or smaller numbers, but we can use decimals with the equation. We can round it to the nearest unit when it comes to our graph, and you could even have said just a little bit above 30 minutes, or 31 minutes, or 32, depending on what your graph looked like. So this is how we can use the graph and equations. We can use the equation to make a graph, we can use the graph to come up with assumptions, and we can use the equation to come up with exact values.